Now in this lesson, we're going to learn how to write a balanced chemical equation. So firstly, what does it mean for an equation to be balanced? Now if we look at the example here, where hydrogen reacts with oxygen to form water. If you take a look at this chemical equation, you may find that it looks incorrect. Now why does it look incorrect? Because if you look at the number of oxygen atoms on the left, there are actually 2 oxygen atoms. And then if you look at the number of oxygen atoms on the right, there's only 1 oxygen atom. So where did the missing oxygen atom go? Right, for equations like this, they look incorrect because it is not balanced or unbalanced. Alright, so what then constitutes a balanced equation? A balanced equation must contain equal number of atoms of each element on both sides of the equation. Alright, so now we look at the same reaction, but now the chemical equation is slightly different. Right, if you look carefully, there's a 2 in front of hydrogen and there's a 2 in front of water. Now what does it mean? It means that in this equation there are 2 hydrogen molecules and there are 2 water molecules. So right now, if we count the number of atoms of each element on both sides, let's take a look at what happens. So if we look at the number of hydrogen atoms on the left, there are actually 4 hydrogen atoms and there are 2 oxygen atoms. If we look at the number of hydrogen atoms on the right, same thing, there are 4 hydrogen atoms and there are 2 oxygen atoms. So what this means now is that the equation is balanced because we have the same number of hydrogen and oxygen atoms on the left and on the right side of the equation. So how then do we balance an unbalanced equation? We do so by adding numbers in front of the substance. I'm going to show you an example now. So if we look at the equation shown over here, alright, now let's try to balance the number of chlorine atoms. If we look at the number of chlorine atoms on the left, there are actually 2 chlorine atoms. And then if we look at the number of chlorine atoms on the right, there's only 1 chlorine atom. Alright, so how do we balance the number of chlorine atoms? Is by adding a 2 in front of sodium chloride. And once we add a 2 in front of sodium chloride, our number of chlorine atoms becomes balanced. Alright, now we look at sodium. On the right, there are 2 sodium atoms, and on the left, there's only 1 sodium atom. So how do we balance the number of sodium atoms? Once again, we do it by adding a 2 in front of sodium. Alright, so once we add a 2 in front of sodium, now the number of sodium atoms becomes balanced. Alright, so now this equation is balanced. Now a word of caution, many students like to do the following by so for example, they take a look at the number of chlorine atoms on the left. There are 2 chlorine atoms and there's only 1 chlorine atom on the right. So what students tend to do is that they will balance it by adding a 2 in front of chlorine. Now you should never ever do that, because when you do that, you are changing the formula of the substance. It is no longer sodium chloride. In fact, this particular formula or this compound with this particular formula does not even exist. Alright, so a word of caution is that you should never ever change the formula of the substance. You can only balance it by adding numbers in front of the substance. Now based on this rule where you balance the equation by adding numbers in front of the substance, you should be able to balance many equations. However, you may run into a lot of difficulties when trying to balance equations. Hence, what I'm going to do is I'm going to show you 4 different hacks for you to balance equations more easily. Now this is the first hack. The first hack is to balance foreign atoms first. Now what exactly do I mean by foreign atoms? Foreign atoms are those that appear to be unfamiliar. Alright, so for example, if you look at many equations, you will see oxygen and hydrogen. So we will balance these two elements last, but rather we look at atoms of elements that do not appear frequently and we try to balance them first. Alright, so if we look at the example given below, one of the foreign atoms I would say would be sodium. Alright, so let's look at the number of sodium atoms on the left and on the right. The number of sodium atoms on the left would be 1, and the number of sodium atoms on the right would be 2. So once again, how do we balance the number of sodium atoms? Is by adding a number in front of the substance. So we need to add a 2 in front of sodium hydroxide. Once we do that, now we end up with 2 sodiums. So now my sodium atoms are balanced. Now the next foreign atom I would say would be sulfur. Alright, so we look at the number of sulfur atoms on the left and we look at the number of sulfur atoms on the right, and we'll find that actually we have 1 sulfur atom on the left and on the right, so it's already balanced. Alright, next we try to balance oxygen. So we look at the number of oxygens on the left and on the right. You would find that the number of oxygens on the left would be 6. And we look at the number of oxygens on the right, we have only 5 oxygen atoms. Alright, 4 from sulfate and 1 from water. So how do we make the number of oxygen atoms balanced? Is by putting a number in front of one of your products. Which one do we want to put? We can put it in front of water. And once we put it in front of water, what it means is that we have 2 water molecules. And that would bring us to 6 oxygen atoms. Alright, so we are done with balancing the number of oxygen atoms. Let's look at hydrogen atoms. Alright, hydrogen atoms, there are 4 hydrogen atoms on the left, and now if we look at the right, there are also 4 hydrogen atoms. So this equation is now balanced. So now the balanced equation looks like this. Alright, let's try to apply the first hack to another problem. So if we look at the example given here, the first thing that we need to do is to locate or to identify the foreign atoms. And the first foreign atom that I want to look at would be again sodium. So there are 2 sodium atoms on the left and there's only 1 sodium atom on the right. So how do we balance the sodium atoms? Is to add a 2 in front of sodium chloride. The next foreign atom that I want to look at will be that of chlorine, and there is 1 chlorine atom on the left and there are 2 chlorine atoms on the right. So how do we balance the chlorine atoms? Is to add 2 in front of HCl. And the next foreign atom that I want to look at would be that of carbon. There's 1 carbon on the left and there's 1 carbon on the right, so that's already balanced. And now we'll look at oxygen. There are 3 oxygens on the left and there are 3 oxygens on the right. And lastly, we now try to balance for hydrogen. There are 2 hydrogens on the left and there are 2 hydrogens on the right. So the equation is balanced. Now the second hack is to treat polyatomic ions as a unit. So if you cannot remember what are polyatomic ions, can you all please go back to the previous lesson where we talked about the formula for ionic compounds. Polyatomic ions essentially are ions that contain more than one atom, more than one atoms in it. For an example would be sulfate, nitrates, and so on. Alright, so what do I mean by to treat polyatomic ion as a unit is this. So if we look at this particular example, there is a sulfate in the equation. There's a sulfate on the left and a sulfate on the right. So we try to balance the whole sulfate as a unit. So since there's one sulfate on the left and there's one sulfate on the right, the sulfates are balanced. Alright, now let's try to balance the other polyatomic ion, which is hydroxide. So there is one hydroxide on the left and there are two hydroxides on the right. So how do we balance the hydroxides as a whole? Is to add a 2 in front of NaOH. And once we do it, we have two hydroxides on the left and on the right. Alright, once you are done, let's try to balance my copper and my sodium. And if you were to inspect the number of copper and sodium atoms on the left and on the right, you would find that they are already balanced. So there's one copper on the left and on the right, and there are two sodiums on the left and on the right. So now this equation is balanced. Let us now try the second hack on another problem. If we look at this equation over here, the first thing that we need to do is to locate the polyatomic ions again. Alright, and I can find that there's a sulfate and there's another polyatomic ion, which is my nitrate. Alright, so when we try to balance for the sulfate, you would find that the sulfates are already balanced. There's one sulfate on the left and there's one sulfate on the right. But when we try to balance for nitrates, you will find that nitrates are not balanced. On the left, there are 2 units of nitrate, and on the right, there is only 1 unit of nitrate. So how do we balance for nitrate? Is to add a 2 in front of sodium nitrate. Alright, and when we do that, we will end up with 2 nitrates. Once we are done with that, let us try to balance for sodium and barium. And you can easily see that the sodiums are already balanced, as well as for your barium. Alright, so the balance equation looks like this. Now hack number 3 is to attempt to balance using fractions and then multiplying throughout. What exactly do we mean by that? Now let's take a look at this example given. So we would apply hack number 1 for a start. So we will try to balance the foreign atoms first. And the foreign atom that we're going to look at would be sodium. Alright, there's one sodium on the left, there's one sodium on the right. So sodiums are balanced. Now we'll try to balance for oxygen. You'll find that there is again one oxygen on the left and there's one oxygen on the right, so it's already balanced. Now lastly we'll balance for hydrogen. You'll find that there are 2 hydrogens on the left and there are 3 hydrogens on the right. So the hydrogen atoms are not balanced. Now if you inspect the equation, is there anywhere where we can add a fraction for the hydrogens to become balanced? Right, there is we can actually put a half in front of this hydrogen, and once we do that, we will have 2 hydrogen atoms on the right. Right, but then it doesn't really make sense. What does it mean by half a hydrogen? Alright, so how do we make this into a whole number? Is by multiplying the entire equation by the denominator. Alright, since the denominator is 2, we're going to multiply the entire equation by 2, and once we do that, we end up with this. Alright, so this is the balance equation. So as shown, there are some equations where we can actually balance more easily by adding a fraction first and then multiplying throughout by the denominator. Now we'll try to apply hack number 3 on another example. So if we look at the equation here, same thing, we will try to balance the foreign atoms first. So the foreign atom would be iron. There is one iron atom on the left, there are two iron atoms on the right. So we have to balance for iron by adding a 2 in front of Fe. Alright, let's try to balance the oxygen atoms now. There are 2 oxygen atoms on the left and there are 3 oxygen atoms on the right. So is there anywhere where we can write a fraction for us to balance the number of oxygen atoms? And the answer is yes, we can actually add a 3 over 2 in front of oxygen. And once we add a 3 over 2, we'll end up with 3 oxygen atoms on the left and on the right. Okay, once again, having 3 over 2 oxygen molecules looks weird. So now we will have to multiply the entire equation throughout by 2. And once we do that, we'll end up with the following. Alright. Let's try one more example using hack number 3. So in this example, the foreign atom would be carbon. So we'll first try to balance the number of carbon atoms. There are 2 carbon atoms on the left, there's only 1 carbon atom on the right. So we need to balance it by adding a 2 in front of CO2. And once we do that, we'll have 2 carbon atoms on the left and on the right. Next, we'll try to balance the hydrogen atoms. Now if we look at the number of hydrogen atoms on the left, we have 6 hydrogen atoms. We only have 2 hydrogen atoms on the right. So how do we balance it? Is by adding a 3 in front of H2O, and once we do that, we end up with 6 hydrogens on the right. The last thing that we need to balance is that of oxygen. There are 2 oxygens on the left, and if we look at the right, there are 7 oxygen atoms. Right? How do we get 7? If you look carefully, there are 2 carbon dioxide molecules, meaning there are 4 oxygens here, and then there are 3 water molecules, meaning there are 3 oxygen atoms here, and 4 plus 3 oxygen atoms gives us 7 oxygen atoms. Now the oxygen atoms are obviously not balanced. So how do we balance it? Again, is to apply a fraction somewhere. And where do we apply the fraction? Is to put it in front of O2. We can add 7 over 2 oxygen. And once we multiply it by 7 over 2, we'll end up with 7 oxygen atoms on the left as well. Alright, so the last thing that we need to do now is to multiply throughout by the denominator. And once we do that, we end up with the following equation. Alright, so this is our balance equation. Now, should you apply hacks number 1, 2, or 3, and you find that you are still stuck, then in cases like this, you have to apply hack number 4. So hack number 4 should be your last resort. When you are stuck and you don't know how to balance, you have to apply hack number 4. What is hack number 4? Hack number 4 is to find the lowest common multiple. Alright, I will illustrate using the example here. So in this example, let's try to balance the foreign atom. The foreign atom over here would be potassium. Alright, so if we look at potassium, there is one potassium on the left, there are two potassiums on the right. So normally we would balance it by adding a 2 in front of potassium. Alright, next we'll try to balance chlorine atoms. You'll find that there are two chlorine atoms on the left, there are two chlorine atoms on the right, so it's already balanced. Alright, lastly we try to balance for oxygen. There are 6 oxygens on the left and there are only 4 oxygens on the right. Alright, can we apply a fraction anywhere? Actually no, because when you apply a fraction anywhere, you will change one of the earlier elements as well. You will change the number of one of the earlier atoms. So at this point in time you are stuck. There's nothing that we can do to balance the equation further. Alright, so when you encounter something like this, we have to go back to the start. Alright, and then the element that we were stuck with was that of oxygen, so we will try to balance oxygen first. There are 3 oxygens on the left and there are 4 oxygens on the right. So the trick here is to find the lowest common multiple for oxygen, and the lowest common multiple is 12. How do we get 12? We need to add a 4 in front of KClO3, that will bring us to 12 oxygen, and we need to put a 3 in front of KClO4. Right, that will bring us to 12 oxygen atoms also. Now once you have done that, usually the equation is already balanced. Alright, so let's check the number of potassium atoms. There are 4 potassium atoms on the left and there are 4 potassium atoms on the right. Alright, next we will check the number of chlorine atoms. There are 4 chlorine atoms on the left and there are 4 chlorine atoms on the right. So yes, the equation is already balanced. So the balanced equation will look something like this. Again, let us try to apply hack number 4 to another example. So again, I'll illustrate the attempt to balance it using hacks 1 to 3, and to show you that you will be stuck, you cannot move any further, and then we'll apply hack number 4 again. Alright, applying hack number 1, we will need to look at the foreign atoms. The foreign atoms here would be phosphorus. Okay, there's one phosphorus atom on the left, there are 2 phosphorus atoms on the right. So normally we would balance it by adding a 2 in front of H3PO3. Next we will try to balance the oxygen atoms, we can actually try to balance the hydrogen atoms first. Alright, if we try to balance the hydrogen atoms, you'll find that there are 6 hydrogens on the left and there are 6 hydrogens on the right also. So the hydrogens are balanced. And lastly, we try to balance oxygen. There are 6 oxygens on the left and there are only 4 oxygen atoms on the right. Alright, so can we apply a fraction anywhere to make the equation to make the number of oxygen atoms balanced? The answer is no. Alright, again the reason is the same. If you add a fraction anywhere to balance the oxygen atoms, you will change the number of one of the earlier atoms that you have balanced. Alright, so at this point you are stuck. There's no way for you to move forward, and we have to go back and apply hack number 4. Alright, so how do we apply hack number 4? Again, we got stuck with oxygen atom, so we're going to start with oxygen atoms again, and again we are going to find the lowest common multiple for the number of oxygen atoms on the left and on the right. We have 3 oxygen atoms on the left, we have 4 oxygen atoms on the right. So the lowest common multiple again is 12. So how do we get 12? We add a 4 in front of H3PO3, and then we add a 3 in front of H3PO4. And once we do that, we'll end up with 12 oxygen atoms on the left and 12 oxygen atoms on the right. Again, once you have balanced the oxygen atoms, which was the one where we were stuck at, the rest of the atoms will naturally be balanced. Alright, so if we can check, there are 4 phosphorus atoms on the left, there are 4 phosphorus atoms on the right. And now we check the number of hydrogen atoms. There are 12 hydrogen atoms on the left, and we have again 12 hydrogen atoms on the right. So the equation is already balanced. So we have already seen the 4 different hacks for you to balance equations more easily. Now how exactly do you know which hack to apply first? Alright, I would recommend that you start with hack number 1. If you see any polyatomic ions, use hack number 2. Alright, if you find that you have some issues with balancing at a certain point in time, you want to try using a fraction, and failing which you will apply hack number 4, where you go back to the beginning and you start with the atom that you are stuck with and find the lowest common multiple. Alright, so for a particular problem, there's no one hack that will get you to the answer straight away sometimes. So you have to try the hacks one by one, and one of them will get you to a balanced equation.